Hi, this is the second half of the video on arrays and array lists. Okay, so we've already looked at arrays. One of the problems with arrays is that they are fixed size. So we need to declare the size of the array when we declare the array and initialize it. And also, if at runtime we want to change the size of the array, for example, we might find that we have more data to store, then we need to redeclare another array of a different size and then copy all the elements over. It's quite time consuming. Much better to have something which is variable length. And in Java, we're lucky that there are a whole set of data structures in something called the collections framework, which we'll look at later on in the course. And they allow variable sized collections to be stored. Things which are included in there are lists, maps and sets, and for the moment the only thing that we're going to be interested in are lists and one particular implementation, the array list. And sitting behind an array list is actually an array. So that means that an array list has the same properties that arrays have, or very similar. So they're indexed, there's a particular position associated with each element, and there's a size. So let's have a look, similar to what we did with arrays, let's have a look at how to declare an array list. Well, we declare an array list by using the object type array list, and then we can create it using the word new and array list and a constructor, just as usual. The thing that's different is we specify the type of the object which is going to be stored in the array list. So here we've declared an array list of type person called people, and then we actually instantiate that array list. So we create an empty array list. We don't need to specify the size, we just create an empty array list, and then we can start adding things to it. So here we've got an array list of person objects. If you don't include the object type, so if you don't include this thing here, person, then what you get is an array list of objects. And that might cause you some problems later on when it comes to assignment, tests for the quality and things like that. So it's always best to include that. And in the latest version of Java, this has become unnecessary. You don't need to specify the object type for the constructor if you've declared it when you in your declaration. Properties, well, I've already said, array list is it's variable size, but it's an ordered list. As we add things, the size changes, and the size or the current size can be found using the method size. So unlike arrays, it's a method, so it's got a set of brackets after it. Indexing is exactly the same as for arrays. So indexing starts at 0 and goes up to size -1, and we can add object anywhere in the list. If we add an object, then all the other elements are shuffled along. It doesn't overwrite the object at a particular position. It will move it along. One of the things I've said all along, or I've said up to now, is when the object is added, you can't actually store primitive data types in an array list. You need to store objects. But there's a useful feature in Java called auto boxing, which will create, for example, down here, it will convert an int value into an integer object. So for each primitive data type, there is a class of objects called a wrapper class. So for int, it's integer. For double, it's double with a capital D. For boolean, it's boolean with a capital B. And Java will automatically convert between the two using a process called auto boxing. And if you haven't met that before, then you should have a look that up or Google that. How can we manipulate array lists? Well, suppose we've got an array list of strings called names. We can add a string to the end of the list by using add.add. We can add it a particular index by using .add, but give the index and the object that's going to be added. So you can see that add is overloaded. same method name being used for two different purposes, but they've got different lists of parameters, so that's okay. We can get the element of a particular index by using .get, or we can get the position of a particular element by using .indexOf, and you can get far more details about these different methods by looking at the API under ArrayList. Right. In the first set of the slides, we've looked at iterating through an array. We're going to iterate through an array list as well, and there are four ways of doing this. We can either use the for loop or the while loop, as we did with arrays, very standard. There's a modified version of the for loop called the for each, and we can also make use of an iterator object. Iterator objects are really useful for iterating through a collection where you want to make a change to one of the elements, or you want to change the collection in some way as you're iterating through, which is quite a dangerous thing to do using the standard loops. We'll come on to that in a moment. So, for loop and while loops, well, exactly. The underpinning of an array list is an array, so we have got something which is very, very similar to how we would loop through an array. For index I, index plus, and we're going to continue going until as long as we're less than people.size. So for arrays, it was people.length, and then we can do something. So here we're just printing out the particular element. So I'm using .get index to print something out. You can do the same thing with a while loop down here. It's exactly the same process, just move things around slightly, and you can investigate that yourself. So for loops and while loops, pretty standard. There's a modified version of a for loop called a for each. The for each loop must loop through the entire collection, so you can't stop until you've gone through the whole thing. So it's a little bit simpler than using a for loop, but it's got that caveat that you have to go through everything. So, for example, if we wanted to go through a collection called people, then we could use for every person called P in people, print out P, the person. So here we're kind of grabbing individual elements, and then we can do something with them within the loop. And this will automatically iterate and change this one, change P to the next person in the collection as we iterate through. Very useful. An iterator class allows you to do the same thing really as we've done in the other loops, but we're allowed to change things in the collection. One of the things that we can do is create an iterator object, and then we can use the hasNext method, which allows us to decide whether there's something else that we can iterate through, or we can use the next method to actually get that element. So an example, it's probably best to see an example. So with the people object that we had, the people collection, I've used here people.iterator. That will create an iterator of type person, and then what we can do is use a while loop to iterate through things. You might not ever have to use an iterator, or the situations in which you use it are pretty limited. You might be able to get away with a for loop, a while loop, or a for each, but it's there if we need it. If we do need it, then I'll explain it again. So here's a quick comparison about the 4 different ways that we can loop through an array list. And a quick summary. Arrays and array list are all used to store a number of items of the same type in a data structure. Fixed number of items, array. Variable number of items, array list. And both collections must be declared and initialized correctly. Okay, I'll just go and answer that phone. Bye now.